Before I start this video, I want to ask you to support me by subscribing to my channel. And please like this video if you find it helpful. And of course, if you have some questions or suggestions, welcome to the comments. And we jump right in.
Hi everyone! Today's video will be about Symfony HttpKernel Component and the request-response lifecycle. So, understanding the HttpKernel Component and the request-response lifecycle is fundamental for anyone working with Symfony or modern web applications. These concepts form the backbone of how requests from users are processed and how responses are generated and sent back. Mastering this flow not only allows developers to build efficient and scalable applications, but also empowers them to extend, debug, and optimize the framework effectively. Typical workflow of the HttpKernel component. First, request creation. The kernel receives an HTTP request and converts it into a request object. Second, event dispatching. Events like kernel request are dispatched to modify the request. Third, controller resolution. The kernel determines and calls the appropriate controller for the request. Fourth, controller execution. The controller processes the logic and returns a response. Fifth, event modifications. Events like kernel response allow further modification of the response. 6. Response sending. The kernel sends the response back to the client. So, let's take a closer look at the request and response objects in Symfony. Understanding these components is crucial because they form the core of how Symfony processes and comments data and sends back responses. Request object. Symfony provides a powerful request object from the HTTP Foundation component, which represents an HTTP request. Its main purpose is to offer a convenient interface for working with data sent by the client. Symfony automatically creates a request object for every HTTP request. You can access this object in two ways. First, via the wiring request stack. This is used in services where you can inject the request stack and retrieve the current request. And second, directly in the controller. By passing the request object as an argument to a controller method, Symfony automatically passes the current object. The request is not a service, but it can be passed to a controller as an argument. Symfony made this exception because the request is a fundamental element of HTTP request handling, and controllers are directly involved in processing these requests. Properties of the request object. In Symfony, the request object provides access to data sent in an HTTP request. It separates the data into several categories, such as form parameters, request, URL parameters, query, cookies, files, and headers. These data are stored in specialized classes called ParameterBag, which provide methods to access and manipulate the parameters. Methods of the ParameterBag class. Each of these classes provides methods for retrieving data, for manipulating the parameters, such as adding new values, replacing existing ones, checking if a parameter exists, and removing parameters. Methods for filtering values. In addition, the ParameterBag class provides methods to filter and convert the values of parameters. For example, the getAlpha method allows you to retrieve only alphabetic characters from a parameter. And filter uses PHP's filter var function for validation with the option to throw an exception for invalid value. Response object. Controllers in Symfony typically accept a request and return a response object. This concept reflects the fundamental essence of web application, processing a request and generating a response. A response object encapsulates all the necessary details to be sent back to the client in response to an HTTP request. It is highly flexible and allows setting or modifying its content, HTTP status code, and headers either during its creation or after its instantiation. Constructor Overview. The response constructor allows you to specify first, content, the body of the response, typically HTML, JSON, XML, or plain text. Second, HTTP status code. The HTTP status code indicating the result of the request. For example, 200 OK, 404 not found. Third, headers, an associated array of HTTP headers associated with the response. Manipulating a response after creation. After creating a response object, you can modify its content, headers, and status code using setter methods. When specifying the content type header, you can include the character set directly. However, Symfony provides the setCharSet method, which is a preferred way to define the char set. By default, Symfony assumes that your responses are encoded in UTF-8, which is widely used standard for web content. Preparing and ending the response in Symfony. In Symfony, before sending the response object to the client, it is often useful to prepare it for compatibility with HTTP specifications and ensure that it adheres to proper standards. Once prepared, the response can be sent to the client using the send method. The prepare method is used to make adjustments to the response object based on the details of the associated request. For example, it can ensure the content type header matches the content format, set appropriate headers based on the HTTP protocol version or client capabilities. You pass the request object as an argument to the prepare method. This is especially useful when dealing with complex requests and responses or when headers need to be automatically adjusted to align with HTTP standards. The send method sends the response content, headers, and status code to the client. It marks the end of the request-response cycle. The send method accepts an optional flush argument. By default, this argument is true, meaning Symfony calls functions like fastCGI finish request for fastCGI servers, or maybe a lightspeed finish request for lightspeed servers. These functions flush the response to the client immediately, allowing the server to finish the request processing faster. If the flush argument is set to false, these functions are not called. This is helpful when debugging, as it ensures that exceptions or issues occurring during the terminate event are visible for debugging purposes. The request-response lifecycle in Symfony, the event-driven model. In Symfony, the request-response lifecycle is powered by an event-driven model implemented by the HttpKernel Component. This model makes it possible to customize and extend how requests are processed and responses are generated. By understanding this lifecycle, you gain insight into how the Symfony framework or any other library using HttpKernel operates, enabling you to take full advantage of its flexibility. HttpKernel at the core of Symfony's lifecycle. At the heart of Symfony's request-response lifecycle is the HttpKernel handle method. This method processes the request by triggering a series of events, where event listeners handle specific parts of the lifecycle. This approach allows developers to easily modify or extend the behavior of the framework. Case steps in the lifecycle. Let's break down the case steps and the corresponding events that define the request-response lifecycle in Symfony. First, kernel request. This is the first event triggered in the lifecycle. At this stage, listeners can modify the request object or even set a response early, for example, for caching or security checks. If a response is set, the process skips to the kernel response event. Second, routing and controller resolution. After the kernel request event, Symfony resolves the route and identifies the controller to handle the request. Third, kernel controller. This event is triggered before the controller is executed. Listeners can modify the chosen controller or add preprocessing logic. Fourth, kernel controller arguments. Once the controller is selected, this event allows listeners to modify the arguments passed to the controller. Fifth, controller execution. The controller processes the request and usually returns a response object. However, if the controller returns something other than a response, the process continues with the kernel view event. 6. Kernel view. If the controller does not return response, this event is triggered. Listeners are responsible for transforming the returned data, for example, array or an object, into response. This is commonly used in APIs where the controller might return JSON data or a view model. 7th, kernel response. After the controller returns a response or after the kernel view event, this event allows listeners to modify the response before it is sent to the client. Examples include adding security headers or logging. 8th, kernel exception. If an exception is thrown at any point during the lifecycle, this event is triggered. Listeners can handle the exception and transform it into a proper response. For example, returning a JSON error for APIs or rendering a custom error page. 9th, kernel finish request. This event is triggered after the request lifecycle is complete. It is useful for cleanup operations or logging. 10th, kernel terminate. After the response is sent to the client, this event is triggered. Listeners here handle background tasks such as sending emails or processing logs. To summarize, let's illustrate everything discussed with a diagram. Sub-requests. A sub-request in Symfony is a secondary request sent into the HttpKernel handle method, distinct from the main request that initiates the primary application flow. Sub-requests are typically used to render a specific portion of a page, such as widget or a fragment, rather than processing an entire page request. Sub-requests behave like regular requests and go through a complete request-response cycle, where the new request object is transformed into a response. However, the key difference is that some event listeners, security or session management, might only act on the main request to avoid duplicating logic or processes. Developers usually create sub-requests programmatically, setting their own attributes. Listeners handling events triggered by sub-requests can determine whether the current request is the main or sub-request using the isMainRequest method of the kernel event class. For example, a listener might skip processing sub-requests entirely to focus only on the main request. And for today it's all. Thanks for watching. I hope you enjoyed this video and see you next time.